Hello everyone, welcome to the channel Simple Science. Today we will study about linear harmonic oscillator. It will be the quantum mechanical treatment of linear harmonic oscillator. For this you need to consider a particle of mass m oscillating along x-axis about its equilibrium position. As you know, the force is given as F is equal to minus kx, where k is the elastic force constant. So if the particle is oscillating, it will have an oscillating frequency. So the oscillating frequency is given as nu is equal to 1 upon 2 pi under root of k by m. This under root of k by m is nothing but omega. So I can write omega is equal to under root of k by m. Now this was about frequency. Next, talk about the potential energy associated. So the potential energy of the particle can be written as V of x, since it is oscillating along x-axis. So V of x is equal to half k x square. We have the value of potential energy. Put this as equation 1. Now this value of potential energy will be substituted in time independent equation. If you will remember, the time independent equation is given as delta square psi upon delta x square plus 2m upon h cut square E minus V psi is equal to 0. We have the value of V substituted here. Delta square psi upon delta x square plus 2m upon h cut square E minus half k x square psi is equal to 0. This is our equation number 2. This equation has solution only at the values E of n is equal to n plus half h cross omega. Here n is equal to 0, 1, 2 and so on. So if you will consider for n is equal to 0, that is for the lowest energy state, the energy E0 is going to be half h cross omega. For n is equal to 1, the energy is going to be 3 by 2 h cross omega. For n is equal to 2, the energy is 5 by 2 h cross omega and so on. Thus, the quantum mechanical linear oscillator exhibits a discrete series of energy. If you plot a graph, then it will look somewhat like this. I hope you are able to see this. This is our first energy, that is the lowest energy E0, then E1, E2 and E3, and these are their corresponding values. Also, the lowest quantum state, that is n equal to 0, possesses 0 point energy. That is, for the lowest state, energy is half h cross omega, and this energy is the consequence of uncertainty principle and does not vanishes even at absolute 0 temperature. So this was all about linear harmonic oscillator. I hope it helped you in understanding the concept. Thank you so much for watching.